This video is sponsored by PCBWAY.
Hey there, this is Seth Schaefer from Team Just Cause Robotics. Today's video is going to be a bit different from my normal stuff. I figured it would be interesting to do a kind of a start to part video for a lower effort November type of vid. This is kind of in the style of a Cloud 42 or Robert Cowan start to finish of making a part. And I also had a pretty tight time constraint on this because at the time that I was filming this stuff, this was 2 days before the RCE event. And I was making the main structural base plate for Shrapnel V2. So this huge 3mm carbon fiber plate that makes up the entire structure of the robot. Pretty important to get that right, and I only had enough material for one shot. This time I'm using my Avid CNC router. I'll talk more about this in a future video, but this router is definitely overkill for cutting carbon fiber. It costs around $9,500 as configured the way that I'm using it, and I have a bunch of upgrades that I added to mine in addition to that. But that's not to say that you can't do this with like a Shapeoko CNC router that costs a third as much or some other cheaper options. If you don't need as large of a cut area, there are lots of really cheap machines on the market, though I would argue most of those probably aren't worth your money when you can outsource to something like CNC Madness instead. I was just in a major time crunch here, so I didn't have time for anything like that. So let's get right into it after a word about PCBWAY, our sponsor for today's video, who also kindly made a part for Shrapnel V2. This awesome 7075 aluminum billet machined component here. You could order 2 of these from PCBWAY for, at time of writing, about $75 in 7075 aluminum. And that's before shipping, but still pretty much cheaper than it costs to even get the material here in the US to make the part from if I were to try and do it myself. And this quality is a lot better than I could get from my CNC router, which just isn't really rigid enough to get such a nice surface finish on an aluminum part like this. So check them out at the link down below and you can get $5 off of your first order. Alrighty, I want to make the base plate for Shrapnel mine out of 3mm carbon fiber on my CNC at home because I think it'll be faster than going to the makerspace to use their water jet. So let's see if I can do it in less than 2.5 hours, starting with just the design and none of the cam work done or any setup on the CNC. Alrighty, so I've got Shrapnel mine here right now. And basically what I'm going to try and do is make all of the cam for the base plate as quickly and efficiently as possible. So my plan will be to cut this out of 3mm carbon fiber. First, I'm going to double check that the piece of carbon fiber I have is wide enough because this is a 182mm wide part. And it is 180mm long as well. So it's about a square. All right, so the material that I have is 8 inches by 12 inches, which is 203mm by something more than that, so should be fine. So first step is going to be, just to make my life a little easier, I'm going to turn the base plate into a component. Oh, shoot, right. Ugh, there's a frickin' outage detected, so I can't save it because there's no cloud storage available. Ah! Okay, so my life is a little bit harder now because there happens to be a Fusion 360 service outage right now, and that means I can't isolate the base plate to work on it separately. So instead, I'm just going to have a work on it in place. So first we'll do a setup. So in this case, our stock is going to be a fixed size box, and we're going to make the height. Well, first we'll do... This is the z-axis plane, and in the machine I'll have it oriented with the x-axis either this way or this way. Let's do it with the x-axis along this edge so it's a little bit simpler. And then I'm going to change the stock to be 12 by 8. And whatever thickness it is. Okay. And now for my origin, I'm going to choose this corner. So I'm in that top left corner. Cool. So now the question is, do I have access to any of my tools? I don't have the cloud library. I do have my local library. Okay, good. So I do have access to my tools. So I'm probably going to do pretty much everything with a 3mm or 1/8 inch end mill. I already have this one loaded in, so we'll just start with that. So to start off with, I'm going to want to mill out most of these holes. I'll have the plate clamped down, mill out a bunch of holes, and then I'll be able to screw the plate down with a bunch of these screw holes to the wooden sacrificial waste board, and then cut out the outside contour, hopefully with no issues. Okay, so immediately the problem with the 3D adaptive clearing is evident, which is that it refuses to go inside of any holes or pockets that are less than twice the tool diameter. So now I'm going to use a boring operation. I'm going to do same diameter, same depth passes, and not passes, heights. I want to go below the hole bottom by negative 0.05 inches. So it should go through all the holes. Now it's selecting all same diameter holes for me. And then these two apparently are slightly different. So that should get all of the holes. We'll figure out some speeds and feeds for everything. I've never cut carbon fiber before on any CNC machine ever, but I'm sure it shouldn't be harder than plastic. It's just that you have to be careful about managing the dust because it's pretty toxic. So I'll be holding a shop vac nozzle up to this the whole time it's cutting. The question is, do they even have carbon fiber or carbon fiber reinforced plastic as an option in HSM Works? Carbon/glass fiber reinforced FR4 is probably going to be the closest I'm going to get. And then I can load an 1/8 inch end mill. So I have like 6 different end mills that are all 1/8 inch. I have 2 flute and I have 1 flute ones. I've got 3 1/8 inch 2 flute solid carbide end mills that are 0.5 inch cutting length. So I'm going to assume I'll be using one of those. And those are uncoated. So my depth of cut is going to be like only about 3 millimeters. So I'll say 0.125 because that's close. And for now, we're not going to be slotting yet. Okay, so yeah, I kept everything. So if I don't slot, it's saying I want to step over 0.0166 inches. Interesting. So first off, we want 22,000 RPM. We want like 45 inches a minute. I'll back off that recommendation a little bit because this machine isn't crazy rigid. Our optimal load is 0.016. And it's actually saying for this, I should go like 100 inches a minute. So I'm going to do, or it's saying do 155. I'm going to say 100 to start with. How long is that going to take? That looks crazy slow. That's too many passes. I'll just change the optimal load to like 0.05 and back off the feed rate a lot. Now for boring, I'll probably do the same 24,000 RPM and just run it at like, yeah, 40 is honestly probably fine. So it's going to take about 3 minutes just to do those pockets, supposedly. That's partly because of the helixes being super slow. So we can change that. Linking helix, let's make it 6 degrees. So now it's only 2 minutes, and then it's 4 minutes to bore all these holes. Now for the boring, actually I think I can go faster than this. I'll go like 70. And then 3 degrees. It's doing so little. All right, so cool. So that's 2 minutes. That's 2 minutes. Now the outside contour is going to be the tricky part, but because I will screw it down in between these operations, I should be able to just kind of go for it. So what I'm going to do is slotting. So I'm going to back off to 22,000 RPM. back off to 40 inches a minute. For linking, I'm going to turn on ramping. I'll do like a 3-degree ramp. And then I'll try and do it in a few passes. Again, I'm going to go 50 thou below, but we'll do multiple depths. Step down 0.05, 0.06, so I should do like 3 step downs. So that's going to be 6 minutes. And then, let's see. I want to do roughing pass with a step over of 0.05. So this will basically make it do, so instead of the slot being the tool width, tool diameter the whole way, it'll do a slot and then another slot that's slightly closer so that the chips don't clog up as much. So it's going to take 12 minutes to do that. Might speed it up to like 50. That's pretty slow, but hypothetically this will work fine. Don't know if it'll work for realsies, but only one way to find out. So total cut time 14 minutes exactly is the prediction. These first 2 cuts are going to happen, and then as long as I don't lose my origin, this cut will happen after, but I just have to put screws in all the holes that the end mill won't run into, basically. So not the ones super close to the edge, but I can put screws in a bunch of random holes in the middle to hold it down nicely. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. I've just increased the decibel level on the transmitter, so there's probably going to be some background noise audible because I have 2 3D printers running, and the CNC is going to be way louder than that when it's actually running. So I haven't used this machine in a bit because I haven't had a need to until now. Wow, that's disgusting. Okay. So first things first, we got to home the machine. Then I have to set up absolutely everything for this CNC job. I also realized I set it to use mist coolant, but I probably don't want that because I'm going to use the vacuum instead. All right, it's been several weeks, close to a month since I've used the machine. This is how I jog the machine around and control it. I have like a little wireless keyboard thing here. It actually has a backlight. It's like next to impossible to see it, but it is there. So what we're going to do is hit enable and then home XYZ and hope nothing horrible happens. So far nothing horrible has happened, so that's a plus. Cool, it homed successfully. Soft limits will now be enabled. Park the machine over there. All right, so the ATC thing isn't quite set up properly right now, so I'm not going to be using that, but it doesn't really matter because I only need to use 1 tool anyway. However, I can open the cover and check to see if this is the end mill that I wanted. Does not look like it is. I don't think any of those are 1/8" tool holders, so let me check my tooling drawer. These, which are the 2 flute carbide 1/8" end mills. And this is a ER20 collet nut with an 1/8" collet in it. So now what I want to do is take this vise off. I technically don't have to do this. I could just bolt the spoilboard down as is. But I don't have a ton of clamps, so I think it'll be easiest to just reuse the ones that are already on there. This only barely fits here and I don't have room for clamps really around it, so let's grab a wrench and we can do that. Alright, so I don't have the spoilboard totally secured. That was a huge waste of time. I now only have 1 hour and 43 minutes left. So here's what I'm going to do. I need to surface an area that I can clamp this to. So I need to figure out where I can clamp this to. Cool. So I know more or less where I'm going to be clamping this now. Now I need to switch to my surfacing bit. This will let us establish a Z-plane for the Spoilboard and then eventually for the stock. What was that sound? Oh my god, are you kidding me? The VFD cable just snapped the plastic. What the fuck? Oh my god, this cable's being worn through. I had no idea that was happening. Jesus Christ. Oh my god. So apparently the way this cable was routed behind the drag chain instead of in front led to this cable dragging on a sharp edge on this aluminum extrusion over and over again. And I hadn't realized until just now when I'd lowered the Z so much that that cable snagged and it broke the housing on the spindle because of how much force that exerted. It had frayed partway through this cable. It looks like it frayed through the shielding, but not through any of the wires, thankfully. So for now, I am going to wrap it in electrical tape, and then I'm probably going to request from Avid that I get a new cable. So thankfully, it is just the cable that's badly damaged and not the VFD, I hope. I just turned it off. I'm going to turn it back on for after the capacitors have all drained and everything's turned off and hope it works now. But with this box kind of broken, that doesn't inspire a lot of confidence. I'll have to epoxy that back together at the minimum. Getting a new spindle will be thousands of dollars, and I definitely am not doing that anytime soon. I've never lowered the spindle that low before, and I just didn't see it as a problem. All right. Fortunately, the spindle is functional. There we go. That'll survive for a lot longer now. All right, so where was I? Trying to lower the spindle without destroying itself this time. Jog rate's super slow right now. Also, I'm going to tell it that its current tool is tool 2. Alright, hypothetically, it should measure the tool. Alright, so basically what it did is I set this tool length parameter here. So when I switch to the 1/8 inch tool, I can tell it it's a different tool number and remeasure, and it should reset the Z heights to match. So now, I don't know if my Z is accurate anymore, but it's probably super wrong. But I can just redo the Z again. Yeah, so it's way off now, but that's fine. Alright, so now I tell it it's at Z of 1 again. Actually don't know what the limit is, but I can check the machine coordinates. So right now the Z machine coordinate is minus 5.77. It should be able to go to minus 8.4, so the spindle nose is almost touching the table, so I should have plenty of room here. Alright, so basically what I'm going to try and do is just manually jog it around to level off a rectangle that's at least as big as the carbon fiber. Cool, so apparently I wasn't recording for literally any of that, but basically I just manually jogged a big spiral around with the CNC, with the bit running at 12,000 RPM and holding vacuum to it the whole time. Before I can do a line to another point, so what I'm going to do is I'm going to exactly the Z. What I'm going to do is just take a little bit of this corner. That's not 0. So, where are we at now? Hypothetically, I now have a perfectly flat level reference for my carbon fiber plate. It's not perfectly flat because the spindle isn't trimmed absolutely perfect, but it's pretty good. This top right corner, I now know the exact location of to within 1 tool radius anyway, is now my 0, 0. So this is going to be my X0, and this is going to be my Y0 for when I'm cutting this plate. Now I just need to secure it down somehow. All right, so what I did is I took a 3mm drill and just went through all 4 holes with this down. Then I pulled the plate off, and over the trash can I drilled 4mm clearance holes in the 4 corners. So now I can screw these screws down to hold the plate down, and the holes will definitely line up perfectly. Shit. Screws are slightly too long. Alright, so now I have belt ground the screws a bit shorter. Might need to add a couple more for extra insurance, or I'll just add a clamp like I was originally going to. Alright, that corner's not going anywhere. My hope is that because this is inset into the Spoilboard, like, it needs to come out of the corner to be able to rotate it all and really skew stuff. So as long as I can kind of keep it from shifting around even a tiny bit, it should stay nice and square. And if the part comes out a little bit longer than it needs to, it's not the end of the world, but yeah. Okay, so I'll just re-zero the Z there. That's truly Z 1.0. It was off by 8 thousandths, like I thought. So now we should be able to send G-code to the machine and basically just start cutting all of those holes out, and then the outer contour once I screw it down some more. Alrighty, so CNC computer, file. Nope, I need to use this mouse because the touchscreen sucks. There we go. So this is what our G-code file looks like. As you can see, there's a bunch of green circles, which is where it's going to cut, and the green pockets as well. And if I zoom out, you can see that the red lines that might not really show up on camera, but there's a red thing right here and here. I'm skewing it. I'll do it back to the top view. So right there is where it says the cutter is relative to where it's going to cut. If I have keyboard jogging still on. So right now I have it basically where the top left corner of the part is. If I go all the way down, now I'm past the bottom of the part. So I know that it's not going to collide with anything because I just jogged it over. So not going to hit my clamps or anything, so it should be fine. Even if I'm going on the outside contour all the way over here, shouldn't hit anything. So now, hypothetically, everything is good. However, I want to be extra safe. So what I'm going to do is go to Z2. So this is exactly 2 inches above the part. I'm going to tell it that it is actually 1 inch above the part. So basically I just told it to go to Z of 2 and then set it to Z of 1. So what that does is if it's going to try and cut now, it's going to cut exactly 1 inch over where it should cut to cut out the part. And that way, if there's anything wrong, I'll be able to tell without it actually marring the material at all. Alright, so I really don't mess around with this stuff. Carbon fiber dust is extremely dangerous, so I'm going to be wearing an N95 mask while cutting and trying to vacuum all of the chips out of the air before they become airborne. Alright, let's begin the air cut. Okay, so I did the wrong thing there. I hit stop instead of hitting feed hold and then reset. So I have to rehome, but it doesn't matter because I didn't cut anything yet. And it should find the same XYZ0 anyway. But anyway, it looked like it was cutting in the right place, so I'm just going to send it after this. Okay, so Z height did get screwed up a little bit, but easy enough to fix. So that says 0, 0 now. And then to XY0 should be that corner, and it still is. Okay. So we are good to go now. Okay, so that is op 1 done. Now for cutting the outside out, op 2, but first I have to screw it all down. The vacuum was surprisingly effective at getting rid of all the chips, really. It seemed like there isn't a whole lot there, and I don't see any marks on the end mill showing that it wore down a lot or anything like that, which is also good news. And we stayed within the bounds that I had drawn roughly, so that's also good. The cuts look super clean, and they definitely all went all the way through. Alright, I'm going to bank on having a lot of screws holding weakly being just as good as a few holding strongly. I mostly just don't want this thing to be able to lift up at all. Alrighty, let's send it, I guess. Alrighty, looks like we did it. And I'm going to keep my mask on for a bit, actually, just in case. Alright, so here is my finished carbon fiber 3mm part. This is obscenely stiff. Like, I think 3mm might have actually been overkill for this. This is ridiculous how stiff this part is. 3mm, probably thicker than it needs to be, but god damn, that is not flexing one bit. Now I just need to put this guy into this guy.